All right, welcome to Psychology, Sociology, and Biological Foundations of Behavior section of the MCAT. So today I'm going to start off with sensory processing. Here's a list of all the topics that you need to know that are listed out in the AMC Content Outline Guide. And so always use that for reference. And instead of every class, I'll go ahead and show everyone what you need to know. And we're going to cover all of these topics in this section. So, basics of sensation. So we need to know what our two types of thresholds are. The first type is the absolute threshold. And so that is the smallest amount of stimulation needed for a person to detect that stimulus 50% of the time. So we see that in this case, right, our threshold is 40. We can see how the stimulus intensity needs to be 40 or 40 whatever units for a person to detect that 50% of the time, right? The probability of detection is 50. All right. And so in this case, if I asked you, right, what is the threshold? The answer would be 40. Now, the difference threshold is the smallest amount by which two sensory stimuli can differ in order for an individual to perceive them as different. Okay. So this ties in to Weber's law, and it states that the just noticeable difference or the difference threshold between two stimuli is a function of the magnitude of the original stimulus. So, for example, if I had one gumball, right, and then I added another gumball, for sure I would notice that there's that significant change, right? However, if I had 1,000 gumballs and I added one gumball in, then it would be much harder to notice, right? And the difference threshold would be much larger. And so this states that essentially, the larger the original stimulus, the larger the just noticeable difference needs to be for it to be detected. So always try to make some connections that you know of, like mine was the gumball, and it will make this concept much easier for you. We also need to take a look at how we differentiate noise and stimuli and adapt as well. So the signal detection theory is a theory that explains how individuals distinguish between meaningful sensory signals and random noise. And so you might have seen this in your psychology classes. You might have seen this table, this graph, or a table as well. So let's take a look at a practice problem. Imagine you're sitting in a soundproof room during a hearing exam. You wear headphones and are asked to press a button every time you hear a faint tone. Sometimes there is no tone at all, just silence. So there's four possibilities, right? There is a tone and you hit the button. That's a hit, right? Miss is when, okay, there is a tone, but you don't hit it, right? You missed it. False alarm is when there's no tone, but you still hit it, right? That's false alarm. And then correct rejection is when there's no tone and you don't hit the button. Okay, so those are kind of our four possibilities. Now, we don't really need to know anything about this graph. Here it is often used to better illustrate graphically how humans distinguish between signals and noise. And you can see this as well. But we don't need to know how to interpret this on the MCAT. Another term that's important is sensory adaptation. So this is where sensory receptors become less sensitive to a stimuli over time, right? And it occurs at this receptor level. That's very important because oftentimes students get this confused with habituation, which occurs more at the cognitive level, right? But sensory adaptation refers specifically to the receptors and how the receptors themselves become less sensitive. They're less likely to fire action potentials. We'll take a look at that over time. Right? And psychophysics is just another term that's thrown out there. It's just the study of how various stimuli and sensations and perceptions that the stimuli evoke. Okay. Now, let's take a look lastly at our sensory pathways and receptors. During the next few lectures, we're going to be looking at various sensory pathways. We're going to look at the gustatory, olfactory, vision, hearing, and other pathways are involved. And so sensory pathways are important because that's how that information is relayed to the central nervous system, right? We have these receptors that transfers information on these sensory neurons, also called afferent neurons. Think about afferent. You can think about that going towards the brain, right? And so onto the sensory neurons and then into the central nervous system, right? That consists of the spine and the brain. And so we're going to look at that a little bit more later. But sensory pathways, immediate hearing, taste, smell, sight, and lots more. So we do need to know what receptors are out there. And this is just with some terminology. Thermoreceptors detect temperature. Think about thermo, right? Thermo. Thermometer. Chemoreceptor. Think about chemicals. Photoreceptor. Think about light, right? When you're taking a photo, right? Light. Mechanoreceptors. Think about mechanics, right? It is detecting touch, okay? And also sound. We're going to look at that when we think about hearing and how those hair cells, specifically the stereocilia, the little tiny hair cells, are going to help us with hearing. Baroreceptors detect pressure, okay? And it isn't just, when we think about it, many times people think about the air temperature, but air pressure, but we also have it being able to detect blood pressure. And we also have nociceptors. So these are going to help us with detecting pain. All right. So that is all for this section. And I'll see everyone on the next one.